Hey guys, today we're going to talk about bullet striations and characteristics on shot bullets. Okay, so bullet striations are also known as tool markings. It's whenever a hard object is brought into forceful contact with a softer object, the softer object will be marked. So in this instance, the gun is the harder object and the bullet is the softer object. So this is what happens when the soft bullet engages the hard rifling interior of the barrel. So bullet jackets are typically made of some softer metals, such as lead or copper, whereas rifle barrels are commonly steel. Studies have shown that no two firearms, even those of the same make and model, make the same marks on their bullets or cartridge cases. So that makes this a individual characteristic and not a class characteristics. The manufacturing process. Use and abuse, all these different things will leave different characteristics from the firearm, and none of these can be reproduced exactly. Firearms do not tend to change much over time, so this allows for firearms that are recovered years after a shooting to be able to be identified. Sorry, I had to pause. My dog was asking to go outside. So getting back to that. So firearms recovered months or even years after shooting can be matched to the bullets used in the shooting because they just don't change. It's pretty awesome, isn't it? Also tests have shown that even if you fire several hundred rounds, the first bullet and the last bullet are almost the same. Okay, so fired bullets can be examined to get the general rifling characteristics such as caliber, the physical characteristics of the rifling impressions, and the manufacturer. Microscopic characteristics can be compared to test-fired bullets from a suspected firearm, and that can be used to determine if the bullet in a crime came from the specific firearm. Okay, so let's look at bullet identification characteristics. Okay, the first one is usually the number of lands and grooves, which is usually 4 to 6, but can range from anywhere from 2 to 22. The diameter of the lands and the grooves, the width of the lands and grooves, the depth, the degree of twist. Okay, and the direction of the rifling twist. It's commonly clockwise, less commonly counterclockwise. All right, so the process of determining whether or not striated tool marks on two objects such as fired bullets correspond is called pattern matching. It's a subjective process, and it's based on observations and experience of the examiner. Quantitative method of describing observed patterns in bullet striations is called consecutive matching Striae. All right, it's an evolving concept in bullet comparison. It was initially proposed in 1959 by al-Biasati. All right, so criteria for identification in three-dimensional tool marks, at least two different groups of at least 3 consecutive matching striae must appear in the same relative position. In three-dimensional tool marks, at least one group of 6 matching striae must be in agreement in an evidence tool mark when compared to a test. And in two-dimensional tool marks, at least two groups of at least 5 consecutive matching striae must appear in the same relative position. So not a whole lot of this makes a lot of sense until it's in practice, but it's the general numbers for how much must match in order to determine if something is perfect. All right. Some weapons, such as Glock pistols, do not make usable striation patterns because they have polygonal rifling, as seen in the image, instead of conventional. In that, you have one group of 8 consecutive matching striae in agreement would result in a match from this type of rifling. All right, so initial examination of a fired bullet. So initially, to determine the general rifling characteristics, that's what the initial examination is for. It narrows down the possible makes and models of the firearm, and we can look for trace evidence that could be destroyed in the course of bullet testing. So when we're first looking at this bullet, we're looking at textile fibers, looking for pieces of paint, bits of concrete, brick, and the pattern of the badge embossed on the nose. we don't want to test this for striation characteristics until we've looked at all these other trace evidence that could possibly be there. And also to note the firearm, okay? So caliber determination. If a bullet is not deformed, its diameter can be measured within a micrometer to determine its caliber. Lead and lead alloy bullets are larger than full metal jacket or semi-jacketed bullets of the same caliber. If the bullet is severely deformed, it's possible to determine the caliber by weighing it. All right. But however, the weight of the bullet will rarely pinpoint its caliber, but will serve to eliminate a number of calibers. Okay, so a 72 grain bullet could be a 32 caliber, but it can't be a 22 caliber. And 72 grain is giving the weight. All right, fired standards. Fired standards are bullets that are fired from firearms to have known rifling characteristics. It's generally simpler to compare each question bullet to a set of fired standards than to other collected bullets at the scene. All right, determining class characteristics. Okay, class characteristics can be determined from expended cartridges. Those are fired cartridges. All right, you can determine the caliber, the shape of the firing chamber, location of the firing pin, set of any extractors or ejectors, if there are any, the size and shape of the firing pin, and geometrical relationship of the extractor and ejector. So all these class characteristics can help you narrow it down to what type of gun was used. All right. You should take care in determining the general class characteristics because a shotgun can be converted into a rifle, and subcaliber cartridges can be wrapped so they fit in larger barrels. So you have to be very careful when you're determining the class characteristics. You also need to determine if the weapon's class characteristics are consistent with those found on the fired bullets. All right, and the weapon must be test fired to obtain bullets and cartridges for a comparative microscopic examination. So you must fire the weapon that you think it is to do microscopic examination. And you can only do that if it operates properly and if the weapon can be safely fired. So if there's things done to the weapon that make it unsafe to fire it, then they can't do microscopic examination. All right, microscopic examination, you use a microscope with an optical bridge. Here is an image. It allows for side-by-side comparison of two bullets. All right, bullet comparison. First, the test-fired bullets are compared with each other to verify that the weapon's barrel consistently marks the bullets that are fired through it. If consistent marking does not occur, then you can't do any further comparison. Okay, once you find a distinctive pattern of parallel striations, then you can attempt to find matching patterns of bullets that you don't know. All right, if no matching pattern, examiner tries to find another distinctive pattern on the fired bullet and continues to search. All right. Most firearms examiners require that identical patterns of 3 or more consecutive striations be found on each bullet for a match. All right, and not all the striations have to be a perfect match, but you need to have 3 consecutive. And this is because debris in the weapon's barrel can make stray markings on the bullet as it's fired. All right, jacketed and semi-jacketed bullets may not expand sufficiently to fill the grooves of the rifling, so therefore you might not see as many skid marks on these. Skid marks are marks parallel to the axis of the bullet. It makes when the bullet initially enters the rifling edges. The surface of the lands will scrape along the bullet surface, okay, before it's fully gripped by the rifling. The term skid mark is also applied to marks near the nose of the bullet caused by contact when the forcing cone of the barrel of a revolver. Slippage marks are made when it slips along the tops of the lands instead of being firmly gripped by the rifling. This happens when the barrel is worn or if it was bored out. It can also result if a subcaliber bullet is fired in a weapon. Slippage marks are hard to replicate in test firings. All right, firing pin impressions and breech block markings on the primer, also called bold face bolt face signatures should be compared first because they can only be produced by firing a cartridge in a firearm. Chambering, extractor, ejector, and magazine marks may be made by loading a cartridge in a weapon without firing it. So you can get other markings without even firing it. All right, so what can you get from analysis? You can get a positive identification, so that class characteristics are consistent and individual characteristics match. All right, you can have a negative identification. The question bullet or cartridge was not fired in the submitted weapon. All right, none of the class characteristics match. Or you can have inconclusive. There is either too little information or the class characteristics match, but the individuals didn't match. There's lots of different reasons where it can be inconclusive. All right, how reliable are bullet identifications? Basic premise is that firearms and tool mark identification have not been scientifically established. So additional research has to be done before we can really rely on a lot of this scientific evidence about bullet striations. All right, so the National Integrated Ballistic Information Network, the ATF, administers automatic ballistic imaging for NIBN partners. That includes federal, state, and local law enforcement agencies. You're allowed to submit digital images made on spent ammunition from a crime scene, and then the images can be correlated against earlier entries. So this is just a database of information about different fired ammunition. Since 1979, the ATF's annual appropriations have prohibited the expenditure of funds for consolidating or centralizing federal firearms licensee acquisition and disposition records. So therefore, NIBN can't be used to capture or store ballistic information at the point of manufacture, importation, sale. So that means when you purchase a weapon, it's not going to be in the NIBN. All right. So typical database entries include type of breech block marking, size, shape, and location of extractor markings, size, shape, and location of ejector markings, size, shape, and location of firing pin markings. These are the most important identifying marks that you will find in the NIBN. All right, drug fire. This is a database that links firearm evidence from serial shooting investigations used in firearm laboratories in the United States. Of the 65,000 processed homicide and murder cases, 5,200 have been solved using drug fire. Examiners from across the country can compare and link evidence obtained in the form of spent cartridges and other ammunition casings. All right, other firearms evidence. Sometimes fingerprints can be found on casing, but most usable prints are rarely found on the firearm. Obliterated and or altered firearm serial numbers can sometimes be restored, and firearms can be test fired to obtain known specimens for comparison for things such as bullets, cartridge casings, and shot shells casings. Firearms examinations can determine the general condition of a firearm and whether if the firearm is mechanically functional. Trigger pull can determine the amount of pressure needed to release a hammer, and other examinations can determine whether a firearm was altered to fire in the full automatic mode. Shot pellets, buckshot, or slugs. You can examine shot pellets, buckshot, or slugs to determine the size of the shot, the gauge of the slug, and the manufacturer. And wadding components can determine the gauge and the manufacturer. Shot pattern examinations can determine the approximate distance at which a shotgun was fired by testing a specific firearm and an ammunition combination at known distances. You learn more about silencers. Those are muzzle attachments that can reduce the noise of a firearm by suppressing sound during firing. Testing can determine if a muzzle attachment was there, and can also determine the measurable sound reduction capability. And a gun parts examination can determine the caliber and model of a gun from which the parts originated. All right, that is it for today. Sorry it was so long, but hopefully we can move on and you can learn more about firearms and bullets.